What happens when the sun goes supernova? Will any of these planets survive or not? Let's find out as I explode the sun and see what happens. There's the sun right in the center of our solar system. Whoa! It's hot and spinning fast. Let's slow it down a little bit. Let's slow it down some more so that we can see the explosion. So as we come out from the sun, we have Mercury, Venus, then Earth. Yeah, let's put the sun back in the center. Mars. Ceres is quite close, isn't it? There we got Jupiter. Where's Jupiter? Further out, we have to go further out. Jupiter there. Saturn. Uranus. Neptune somewhere out there. Neptune, then Pluto. And then we got some asteroids, comets flying around. And that's basically our solar system. So, if the sun explodes, what's going to happen to the planets? Will they survive or not? Let's slow it down so we can actually get a chance to see what happens to the Earth, especially the Earth, and then see if Jupiter survives, the giant planet. Where's Earth? Then I want Earth, so we'll click on Earth. There's Earth. Its current temperature is a bit cool, 14 degrees average temperature, Earth mass. So now I'm going to explode the sun and we're going to see what happens. Yeah, we're running at around 5 minutes per, about 2-3 minutes per second. There it goes. Whoa! Earth, what's happened to the Earth? Temperature's rocketed, it's gone. See, when I slowed it down, the Earth is gone. Within 10 minutes it was gone. And there we go. Alright, let's go into zoom into Jupiter. Let's see what's happening to the giant Jupiter. Whoa. What's happening to Jupiter? Let's have a look what its mass is like. 310 Earth masses, 309 is dropping fast. So the Nebula is blasting material off the planet. 305 Earth, look at temperature, 1 million, is going crazy. Spinning super fast. Densities dropping. Radius is dropping. It's now 296 Earth masses. Will it survive? Will what's left coalesce around Jupiter? Oh, there it is in the middle of the supernova. How big's it got? Has it consumed Pluto? Where's Pluto? So Jupiter's continuing to shrink. 280. Where's Pluto? At least is it in Pluto? I can't even see it. Pluto gone? Alright, oh there it is, I can see it. Alright, let's see what the state of Pluto is. I think the Jupiter's is shrinking. I think it's going to stick around for a while. Let's have a look what poor old Jupiter's doing. Alright then, let's have a look. Jupiter, what is it? 5,500 degrees. Radius is shrinking. Oh, it's got a little tail now from the Nebula window. Okay, that. What's this? Okay, the tail. It's got a huge tail as the material is being stripped off the planet. Shrinking fast. What is? Mass is shrinking fast. It's got size. Look, kilometers. It's going to disappear. If I speeded this up, it's gonna be it's gone. It's gone. Jupiter's gone. I mean, Pluto's gone. Let's see if Jupiter's still around. Or is that gone as well? Right, let's exit that. Here's Jupiter. Can't see it. I think all the planets are gone. SuperNova, yeah. Where's the Jupiter? Is that what's left of Jupiter? What's that? Some little rocks. I can't see any planets. They've all gone. Even giant Jupiter's disappeared. I am not seeing any planets. Right, let's see how far there's none. So SuperNova. You got little remnants. They're basically all being stripped bare. Alright, SuperNova, so where these supernovas, that's probably where planets were. They're gone. So that's what happens if the sun went supernova. Basically, all the planets are gone within a few years. Not even a year. Alright, let's see how big this nebula will get. Let's speed it up now. See how far it extends. Let's have a look. Whoa. This is 10 years on now. 15. It's just continued to expand. 20, 30 years now. 30 years since it blew up. 40 years. 50. The nebula is expanding. Supernova nebula just continues to expand well beyond the solar system. So it's many times the size of the solar system now. It's about what, 100 years since it went supernova. It's just getting more and more diffuse. I think we come to the limits of the simulation. Light, what's a supernova is distant? It's 24 light years. So radius 24 light years. I don't know what the radius of the solar system was, but it wasn't a light year. It was less than a light year. I'm sure it shows something like 0.6 of a light year from the sun to Pluto, and now we're at, it's just continuing to expand. We're nearly at 40 times, and it's about what, 300 years, 250 years. 40 light years, about 50 times the size. So that's what's going to happen. You got something in the middle. So that's what happens if the sun went supernova. It would expand, it would obliterate all the planets. Inner planets within 10 minutes and the outer planets within a year. They would just be wiped clean. They'd be blasted away, the mass would be blasted away, and the supernova would just continue to expand well beyond the size of the original solar system. Now this is now, radius is 60 light years. That is massive. That's 100, about probably 150 times the original. This is 150 times the size of the original solar system, and it's just continuing to expand. Oh, there it is, right there's a little pinprick, but it's continuing to expand. If I speeded it up, what is it now, about 500 years. Let's go even more. Well, it's still expanding. 1,000 light years. It's just continuing to expand. It doesn't slow down. We're now at around the 3,000, 4,000 years. Yeah. Yeah, I think I'll slow down the time. How many years? I can't even remember how many years now. It's lapped. Oh, it's about 10,000 years now. And the size of the supernova is 2360. It's massive. Let's see how big it gets. We are now at probably 20,000 years approaching. 20,000 years. I slow down. 20. Let's slow it down. So basically, it's stabilizing at around 2,663 light years after about 25,000 years. So it's stabilizing at 2,663 light years. Light year, that is around 5,000 times the radius of the solar system. What's this? Mass is equal to one sun. Radius is 2,663 light years. What's this? Velocity. So it's stabilized. It's no longer expanding. And this is after about 25,000 years. So that's what happens when the sun goes, if the sun goes supernova. No planet will survive. There's no point even thinking about having a colony on Mars or even on Pluto or Charon. It will just blast everything out of this way. You could even go to the edge, way beyond Pluto. It wouldn't survive a supernova. The temperatures, even Pluto was running at around 6,000 degrees. Nothing will survive a supernova. If the sun goes supernova, you won't survive, even if you're a light year away, even if you're outside of the solar system. I think Voyager is 1.6 billion miles away. That wouldn't survive. It wouldn't. Nothing would survive. So now you know what happens if the sun went supernova. Nothing would survive. All the planets would be obliterated. Inner planets within minutes, 10 minutes. As soon as the shockwave hits, they'll just be gone, blasted. The outer planets, Jupiter, they might survive a few months, maybe a month, but then they'll be stripped clean. Pluto, I thought that might be far enough to survive, but no, that's gone as well. Everything will be gone. Nothing would survive the sun going supernova. So don't make any plans of surviving the sun going supernova. Mars, no chance, not even Pluto. They would all be burning, blasted by the wave, shock waves, every planet and beyond. This is 2,663 light years radius. That's the radius, not the diameter. Radius. It'd be massive. 2,000, that should reach other stars. Is that correct? Am I reading this correct? Origin. Max cloud radius. So basically, I know it's not showing any other stars here, but you would reach other stars. That also warns, if a nearby star goes supernova, within 1,000 light years, there are stars within 1,000 light years, if they go supernova, we're going to eventually feel it. It might take thousands of years, but we're going to feel the force of a supernova. If a nearby star, say within say 500 light years, went supernova, the blast would wipe this planet. Looking at what's happened here, within 500 light years, a star going supernova, and the Earth would not survive. The temperatures it would just send the temperatures soaring. The Earth as a body might survive, but there would be no life. It would be in the atmosphere, and everything would have been blasted away. Yeah, it would not survive. So you learned something there. The power of supernovas. They might give birth to solar systems, but they can also wipe them out. So we have to keep a close eye on all those stars within 500 light years of Earth, because any big enough to go supernova, well, they can destroy the Earth, and it will be pretty, well, in astronomical terms, it will be pretty quick. You know, a few tens of thousands of years. You know, although it takes like, 500 years, it could be much sooner, depending on how fast the shockwave is traveling. I think if it's within 500 light years, it would be within probably within 5 to 10,000 years, depending on how far the star is. So supernovas can be devastating. Luckily, our area of the galaxy is not that populated. Otherwise, the Earth would not be still around with life on it. And there are some studies say that past supernovas have led to mass extinction events on Earth, which, following this exercise, I wouldn't be surprised about. Because look at the size of this. And do subscribe for new videos.